This is the Real Tom Rose, and we're dealing with an interesting question here. It deals with real and imaginary numbers. So they say, which of the following has a solution set on the real axis? This is sort of a code for saying which one of these inequalities is there some solution number that is a real number which satisfies that. So that might sound to you like a sort of a crazy question, but let's look at one example. So take this first one, x squared less than -1. Well, when you square something, it always becomes positive, right? You take any number you want, you square it, it becomes positive. So there is no real number that you can square and get a result that's less than -1. So this just doesn't exist anywhere. That's another way of saying has no solution set on the real axis. So we're looking for one of these that does have a solution set on the real axis. Another way to put that is there some value of x which one of these answer choices there's a value of x that makes that statement true. So you can get rid of the ones that are squared with negative numbers, so you can get rid of that one too, because again, when you square something, it won't be negative ever. I'm always super suspect of none of the above answers. So we're really down to these two, right? These two inequalities. This one should be greater than 0, by the way. I'm not sure why it doesn't say that. And from here on out, you could be more mathematical about this, but I think you can pretty much kind of just pick numbers for x and see if you can get it to work. So this first one, for example, it asks for a solution that's greater than 0, and all of the terms are positive. So you can see that pretty much any regular number for x is going to work here. Like pick x is 2. If we take 2 squared plus 2 times 2 plus 2, well, that's a lot of 2's. Is that number greater than 0? Yes. I don't even know what it is. 4 plus 4 is 8 plus 10. Is 10 greater than 0? Yes. So this one, the second one, has a solution set in the real axis. So that's your answer. And if you try it, this one, there's no numbers that will ever make this one work. So I like to just kind of play around at that point until you can show that it works.